Hi, this is Krishnan. Today I'll be covering the talk on securing hyper-converged infrastructure. Let me start with introduction. I am Director Engineering at Cisco System. I head Cisco's hyper-converged infrastructure group in Bangalore. As part of this talk, I'll be covering our experience of securing Cisco's hyper-converged infrastructure. As part of this, the audience will learn the principles that go behind building a secure data infrastructure system. Okay, so let me start with why is it an important problem to solve. So I'll start with a famous quote by British mathematician Clive Humbe, which says data is a new oil. What it means is data is an important asset in the digital economy. If data is an important asset in the digital economy, data infrastructure products are custodian of the data. Because data infrastructure products like HCI are custodian of data, there is a growing frequency and sophistication of attacks that happen on data infrastructure products. And these attacks cost millions of dollars, and not to say the reputation which is at stake for organization. And we hear this. We hear attacks that happen on universities. We hear about attacks happening on hospital infrastructure. We hear about attacks happening on banking system. We hear attacks happening on government infrastructure. So now that we covered the motivation, I would like to actually touch upon why is it complex for the HCI system. The HCI system is essentially a data center in a box. It has elements of hardware, it has elements of firmware, it has elements of storage, network, compute, hypervisor, guest VM. So the threat surface is multi-layered, and there lies in the complexity of securing a HCI system. So how did we approach solving this problem? We approached solving this problem by following the philosophy of zero trust security. So what it means is security attacks are perimeterless. It doesn't differentiate whether the element is inside the network or outside the network. So we ended up using the same philosophy when we went about securing the infrastructure. We didn't differentiate whether it is to do with the code that goes in building the infrastructure, or whether it is about the platform, hardening the platform, securing the whole access of the system, securing the disk drive that hosts the data. Okay, so let me start with the first element that went about in securing the infrastructure. The first element that we looked at is the secure development lifecycle. So we started off with getting the buy-in that it's important for us to solve the problem. And business takes this as a priority to make an investment to secure the infrastructure. So there are three elements to this. One is the requirement. The second is the build aspect. The third is the operate aspect. On the requirement part, what we did is we ended up using threat modeling as a means for us to understand what are the surface attacks that are there on the system, and what is it that we have to address. So this essentially became the product baseline document, and this was the goal against which we were working towards in terms of securing the system. Now that we covered the requirement aspect of it, the second aspect of this is about the build. So this is about applying secure design principles, secure coding practices, secure testing practices. So on the coding aspect, I would like to call out, we found the OAuth standard to be the gold standard in terms of referring and understanding what are all the patterns in the code that could potentially open up the holes, and how do we go about fixing it, right? And on the testing aspect, there are two things. One is the static code analysis, which looks at tools that looks at the system and tells from a code standpoint what are all the vulnerabilities. And then there is the dynamic code analysis, right, where we inject faults or vulnerabilities into the system and understand how the system behaves. Right. The third aspect to this is about the operation. So we came up with security readiness criteria that actually became a guiding principle for us to know whether the product is ready to be shipped. And once the product is shipped, we ensured that we do continuous monitoring and update. So here I would like to mention use of tools like Tenable and Qualys, which helps us keep monitoring the system from a security vulnerability standpoint, and also give us pointers on how to go about addressing it. So now that I covered the first element that went about in securing the infrastructure, we will talk about the second element. So the second element in securing the infrastructure is the robust infrastructure, or the platform hardening. There are three elements to this. So one is the boot, which is about assuring that when the system boots, it boots in a way that it is from a trusted partner, right? So this involves the boot drivers, the kernel drivers, the bootloaders from a trusted party. The challenge for a HCI system, as I said, it's not a single system. It is multiple systems put into a single appliance. So we had to build a trusted chain of dependency when we boot the system, right, starting from booting the firmware to booting the operating system to booting the data platform, booting the hypervisor, booting the guest VM where the application is hosted. So now that we covered the security aspect from a boot standpoint, the second aspect in this was about securing the data in motion. So this refers to processing of information. What are the standards to be applied? So here I would like to call out US Federal has done a fantastic job in putting together a standard called FIPS, which is a Federal Information Processing Standard. And this gives a guidelines on how do we go about securing the information processing between the user or the client and the system. And there is also mention about all the crypto libraries that have to be used. And most of those crypto libraries, what we've, in our experience, we found is available either through the programming language, or there are frameworks that we could use. And last but not the least, in the platform hardening is about limiting the commands that can be executed, or in other words, restricted shell. Here we used the limited shell that is available in different flavors of Linux, and limited shell provides ability for us to limit the number of commands that can be executed. So we have ended up using limited shell and complemented this with a consent token workflow, which authorizes the user who can execute the commands on the system. So that covers the second element that went in securing the infrastructure. The third element refers is about encryption of data at rest. Imagine you had a cache in your cupboard at home, and there was a thief or intruder who gets into your house and gets access to the cache that is there in the cupboard. What if there was a technology that made the cache in a way that was unusable if it were to be in the hands of the thief or the intruder? Well, no such technology exists in the real world, but thankfully there is one on drives, and this is called as encrypted drives. Encrypted drive is a technology that allows us to encrypt the data that is stored in the drive in a way that it becomes unusable if it were to be accessed by an intruder. Right? So here I would like to call out the TPM standard, the Trusted Platform Open Standard, and use of crypto processors to encrypt the information in the drive and make it unusable if it were to be in the hands of the intruder. So in addition to the drive encryption, I would like to call out most of the hypervisors provide encryption in the hypervisor, where we can encrypt the workloads that are executed. So that covers the third element. Right. The fourth element in this journey was about securing the identity and access. So there are two parts to this. Right. One is authentication, another one is authorization. Imagine you had your home door with both the lock as well as the key in the doorknob. Interestingly, a lot of customers have a similar experience where they end up not changing the factory shipped credential, and that gives an opportunity for an intruder to get into the system with ease. To solve this problem, what we have done is we have ended up hardening our authentication two ways. One is multi-factor authentication, another one is single sign-on. In a single sign-on, what happens is the organization has specified the standard credentials that have to be used, and these credentials are provided by the identity provider, and the same credentials can be used to access different endpoints or different services within the organization. So here I would like to call out the usage of the SAML protocol. So this protocol is a glue between the identity provider and the service provider. So service provider at the endpoint refers to the service. In our case, it is our infrastructure service. And on multi-factor authentication is a mechanism of authentication that challenges the user to provide multiple level of authentication to prove that he is indeed the rightful user to gain access into the system. So here we use authentication, the regular username password, in conjunction with an authentication generated on a hardware token. In our case, it is an OTP that is sent to the hardware device of choice by the end user, right? And this covers hardening on the authentication. We will actually talk about the authorization part. So the authorization part refers to limiting the access control on the system depending on the role. So if he's an operator, we will limit the kind of operations that the user can perform compared to an admin on the system. So the last and not the least element on securing the infrastructure is the security audit and reporting. So this is about building a monitoring or observability system that looks at the system on a continual basis from a threat perspective and tells the customer what are the potential threats on the system and provides a recommendation on how to go about mitigating those threats. Now that we covered the different elements that went in securing the infrastructure, what is the outcome of doing all these things? An outcome of doing all these things is we built a trustworthy system. From a customer standpoint, we have reduced the incidence of security attacks. We have lowered the risk overall to the customers. Okay, I would like to conclude the presentation, but giving an analogy of we as users who keep money in our bank, and bank is an institution of trust. Similarly, when a customer makes a choice of persisting data on our infrastructure, there is an inherent trust the customer has that the system is trustworthy. It takes years to build the trust between the customer and the system, and a matter of seconds for that trust to break in the event there is an incidence. And it takes forever to repair or reconcile the trust that is lost. So the concepts that I talked about, while it was in the context of a HCI system, many of those concepts can be applied for a converged storage system or an enterprise storage system to build a trustworthy system. So with this, I would like to conclude my presentation. Thank you.